Welcome to the presentation IP-capable data logger OTT netDL, an investment for the future thanks IP technology. My name is Peter Scheffeler and I'm the responsible product manager at OTT Hydromet for data loggers. I want to talk in this presentation about the subject IP-capable data loggers and as an investment for the future thanks IP technology. What I'm going to talk about now is introduction of the new IP-capable data logger OTT netDL, the possibilities of communication, the advantages of the IP data transmission, used formats and protocols, as well as communication scenarios. Let's start with the features or the main features of the new platform of OTT data loggers called OTT netDL. So the key and main features are the support of Internet Protocol, support of IP-based transmission technologies like FTP, HTTP, HTTPS, SMTP, and so on, by an integrated IP stack. Communication is a very important feature of the new data logger. So there's support of modems, of ISDN, of satellite transmitters, of GSM, GPRS, LAN, DSL networks. The data logger supports push and pull operation as well as redundant communication. Also very important for data loggers is the friendliness of operating. So it's very easy to parameterize this data logger by an intuitive operating program, a simple parameterization via web browser, or remote management via internet. The software of the new data logger is a modern real-time operating system which gives flexible extension possibilities for future protocols and applications. And here again, the keyword, an investment for the future. Software runs on a hardware, and the hardware provides a flexible sensor connection concept, very low power consumption, and standard interfaces like Ethernet, USB, and RS-232. What are the available interfaces of the OTT netDL data loggers? The OTT netDL data logger supports STI-12 protocol. You can connect here any STI-12 sensor from the market which is in accordance with the STI-12 standard. What you see here are OTT Hydromet sensors like the RLS, the CBS, the SE200 or the PLS, but of course you can connect here any STI-12 compliant sensor. The same is also possible via the RS-485 interface. This gives the advantage or provides an advantage to realize cable length of up to 1 kilometer or even a little bit more than that. Then the data loggers are featuring impulse and status inputs. 2 or 4 depends on the type of data logger. Analog sensors can be connected to the data logger with current and voltage inputs, as well as analog outputs, 4 to 20 milliamp outputs, plus additional status outputs, and switching outputs, for example, to connect external devices and switch them on or off, also in order to save power. And last but not least, communication. USB, RS-232, LAN, integrated modem, satellite, and so on. And about the communication I will talk more in this presentation and will explain in more detail what possibilities are given from the product and from the protocols used in the product. Let's have a look at the configuration or the configuration possibilities of the OTT netDL data loggers. We see here 2 types, the netDL 1000 and the netDL 500. So we have a little brother and the big brother. Both are featuring a display with jog shuttle where you can get extensive information about the logger, the sensors, the values, and so on. You have USB ports, host and device. The logger is powered by 9 to 28 volt DC. As mentioned earlier, the loggers are in accordance with STI-12 standard. be 1.3, but of course also backwards compatible to version 1.2 or 1.1. RS485 interface with the STI12 protocol on this interface, impulse and status input on the netDL 1004 at the netDL 502, then serial ports RS232 full DB9 at the netDL 1002 at the netDL 501. Both netDLs are offering the possibility to have an integrated modem and also the possibility to realize voice announcing. There are two different options to do this, one with external modems or with the internal modem in a future release. Both possibilities are offering certain advantages. And we have an Ethernet 10 base T port on the netDL 1000 to connect the data logger in a Ethernet network. The whole concept is very flexible, therefore there's a possibility to add additional interface cards. At the netDL 1000 you can add 3 interface cards, and at the netDL 502. Available interface cards are an analog input card with 2 analog inputs, an analog insulated input card also with 2 inputs, an analog output card, a serial input card which is used mainly for odd sensors, and a barometric input card. These cards can be mixed within the netDL in any order which is desired. Now talking about communication, odd netDL data loggers are true communication all-rounders. They are supporting a wide variety of communication media and therefore give for almost every application a possibility to choose the perfect communication path. We have here the internal modem, GSM GPRS. The modem is integrated in the logger and of course fits for this reason perfectly with the hardware, firmware and software and is an integrated part of the whole concept. But it's also possible to connect external modems to the data logger. Analog modems, ISDN modems, GSM, GPRS modems. We saw that we have RS232 interfaces on the netDL 501 at the netDL 1000. And those can be used for the connection of external modems, as well as to connect satellite transmitter OTT HDR 1200 supporting GOES or Meteosat. And as mentioned, for the netDL 1000 networking Ethernet 10 base T to connect to your company network or to any other Ethernet network or to a DSL network via a DSL router. And last but not least, the local interfaces, the USB ports, host and device, and the RS232 ports which were already mentioned. Now the title of the presentation is IP-capable data logger. What are really the advantages of IP data transmission? First of all, we use standardized protocols like FTP, HTTP, HTTPS or SMTP. These protocols are standardized and of course well known in the IT world and used in various applications. All of us know the HTTP protocol from the internet, or FTP protocol downloading data, or SMTP using email programs. Open formats. The data logger supports OTML, which is an XML based data format, XML extended markup language, an open format, and we have here an odd version of an OTML which is based on this standardized open format. ZRXP, which is also a format which is very widespread in our industry. And as mentioned, the advantages are that those are standardized protocols and formats allow an easy integration in existing IT infrastructures. We can realize parallel data transmission, which is reducing transmission cycles. We will see this later in this presentation. And also one very important aspect, use of inexpensive GPRS volume contracts instead of more expensive time-based contracts, if we talk about mobile communication. Now, IP communication. There are various ways how to realize a communication. I want to show here now two examples. One is the data polling and the push operation, and the differences between those two technologies. Here we have a data poll system. We have various measurement sites where you collect data, and this data is polled from a data center via modems and the telecommunication networks. The data is then used to create alarms, to export it to databases, or to display the data in the internet. How is this working? The data is pulled from the first measurement site, then it's pulled from the second measurement site, from the third, fourth, and so on. And all this time which is needed to pull the data sums up to a total time. So this takes some time until you have pulled all your data from your measurement sites. Now let's have a look at push operation. We have again measurement sites. We have a data server with a connection to the internet, and now the measurement sites are pushing data to the data center via the internet using different protocols like FTP, HTTP, SMTP, or HTTPS. And what is the difference to the polling or to the data polling? You have a simultaneously transmission. So that means this is a much more effective way to transmit data to your data center. Let's take a look at an example for an IP data transmission. You have a measurement site, for example, now with this new data logger from OTT netDL 500 or 1000, and you transmit this data to a data center. First of all, you establish an IP connection via GPRS or the LAN router. So the data logger gets an IP address. This can be dynamic or dynamic via DHCP, or the data logger has a fixed IP address. Then a connection to the server is established with a symbolic address or with a fixed IP, for example, www.com as a symbolic address, or a fixed IP address as it can be seen here as an example. As soon as this connection to the server is established, the data are sent with the chosen protocol, which could be, again, HTTP, HTTPS for secure data transmission, FTP or SMTP. And the data are sent with the chosen format on the protocol, which could be OTML, the MIS protocol, OTBinary, CRXP, DDP. OTML actually includes also metadata, like signal strength, battery status, which gives you a lot of more information about the status of your measurement site. And the data logger receives an acknowledgement from the server. Now let's go into a little bit more details and take a look at an FTP data transmission. We have a measurement site again and an netDL. We have an FTP server. We have a data center. How does it work? The data is sent via FTP to the FTP server. It could be on GPRS, on DSL, or on PPP. Then the data is available on the FTP server. The data center downloads the data from the FTP server and uses it for any application. Could be a software like Hydro 3 or Soda to display data, or export it to a platform which displays data in the internet like the OTNet view. What is the advantage of this? The FTP server actually could be located outside of an internal network, and the data is downloaded asynchronous into the internal network by the client. That means you download the data from the outside FTP server or internal FTP server whenever you want. Now take a look at HTTP communication with commands, which is a special situation here. We have again a measurement site with an netDL, and we have an HTTP server, On this server runs, for example, Hydra 3 Pro, which is the odd Hydromet software package, or Whiskey Soda from Kisters. So what happens? We have a data transmission with OTML format, the XML format I mentioned earlier, via HTTP. So data are pushed from the data logger via GPRS, DSL, or PPP to the HTTP server. At the same time, on the HTTP server, a command can be stored for the data logger on the server. The command is then sent to the data logger and is acknowledged that the data logger has received the command. What is the advantage of this approach? We have an open interfaces, protocols and formats to ensure an easy integration in existing IT infrastructure. We have an XML-based data command format, which enables systems for extensions in future. Coming back to the title of the presentation, Investment for the Future. Data logger settings can be adjusted without a physical connection to the logger, offline configuration. The huge advantage of this is the logger is not visible in the internet during configuration. The configuration is done on the server and placed on the server, and then the data logger requests by a command this new configuration, for example, and executes it. And what is also a huge advantage of this, parameters of a measurement networks can be changed centralized. That means I can do changes on an HTTP server and provide these changes then to all data loggers in the field by an automated command. Now let's talk about some specific things like a maintenance window. During normal operation, it's not necessary to have a connection to the logger. But if you need that, you can define a maintenance window and can establish a connection to the logger. There are three possibilities how to do this. The data logger accepts incoming calls by modem and odd protocol processing. So you have the possibility to parameterize then the data logger with the operating program. Another possibility is at an incoming call or an SMS, a connection to the server is established. The data logger is not visible in the internet but can be reached now. We see this here. You send an SMS or call the logger, and then a connection to the server is established. Or the logger is accessible via integrated web server, and the logger can be parameterized via the web browser. Web interface. The new data logger features also on web interface. That means the logger can be operated and data retrieval can be done via web browser. What is the advantage? You have access from everywhere. You don't need a special software. You only need an internet browser with a flash player. And with these tools, you have the possibility to see your data, to see the status of your logger, the configuration, and so on. That means you have access to your logger from wherever you want. Now let's talk about communication options. There are situations where you would like to establish redundant IP communication paths. Maybe because you want to have the data on two different servers on two different locations, because two groups of people want to share the data, or you just want to have a backup of your data. And now you have the possibility to send these data to two different servers, and you can also have here a blend of protocols. That means you can send data to an HTTP server and redundantly also to an FTP server. Another new feature on this data loggers is time synchronization, which is now possible via SMTP. The data logger gets always the accurate time from an NTP server. IP communication in general, configuration of communication in data logger. we saw now here are many possibilities how communication can be established. That means it's maybe a little bit difficult to set up the communication in the configuration. To make this very easy for the user of data loggers, OTT came up with a configuration tool which makes it really easy to set up the communication by offering a wizard. The wizard steps you through the setup process step by step, asks you what you want to do, you confirm what you want to do, you go to the next step, and so on. And this guides you very easy and very comfortable to a configuration of a complete communication scenario. But that's not all to make it easier. Further features of the operating programs are you have the possibilities to use templates for measurement channels or to create your own templates for measurement channels. If you need measurement channels more often and they are more complex, you can save it as a template and you have it available at any time again. Meaningful failure message means if you configure the logger and the configuration is not consistent, you get a message there is a problem and actually what is the problem, so you can easily correct the problem. Automated support during configuration and plausibility checks. So the goal was here to make it as easy as possible to handle this data logger. Why is this also so important? Not only the configuration of the data logger. We talk now about IP communication. When we talk about communication, there are a lot of potential failures during communication, which are not even related to the data logger. And I want to show here a scenario what can happen during a communication. First of all, we have a measurement side and we do here some measurements. We get some data and want to communicate this data to a data center. So first of all, the sensors are connected to a data logger. Okay, then the question is the configuration okay in the data logger? Does the configuration fit with the sensors, the measurement cycles, and so on? Then we want to transmit data with a modem. So is the connection to the modem okay? Is the cabling okay? Is the contract of the modem okay? Do we have the right SIM card, the right contract, and everything? Is at this location the signal quality sufficient? Is the bandwidth available? Do we have the right data format? If we go to a server, do we have the right configuration of the firewall? Are there any routers involved? Are there proxies used, and so on? Is the server available? And really such simple things, is the username and password okay? And as you can see here, there are many points of failure in such a communication where you could have a problem. And now the real challenge is to find out where is the problem. For this reason, we added a lot of features to identify problems. So there's a detailed event log with informations available in the logger and which can be downloaded. This can actually also optional transmitted as OTML format directly with the measurement data. So you have all the time with your measurement data also this kind of information available. And what is also a very good feature, it's a so-called diagnostic dump, which allows to receive all relevant information by pushing one button, which offers a simplified analysis process. And what you get is then all the information regarding your transmission, regarding your measurement, regarding your measurement channels, and so on. So with this file, it's very easy for experienced users to find the problem, or if it is sent to OTT Hydro service, to find out what is the problem if a communication or a data retrieval fails. So we talked also earlier about simplified management of measurement networks, which is a huge advantage of this new approach. You have the possibility to offline parameterize your data loggers. So you can do the parameterization for all your data loggers in your office offline. You can check, do you have the right parameterization, and then you can update all data loggers automatically. You have the possibility to do the web parameterization. We saw that earlier. The possibility from wherever you are with no special program, just with a web browser to see, okay, what's going on with my data logger. You can have automated updates and new configuration. When you have done an offline parameterization, you can automatically update this to your data loggers, which means a simple maintenance of measurement networks. We have the possibilities to simultaneously transmit data, and we have redundancy mechanisms. All these features are helping to simple manage larger measurement networks. And this all adds up at a cost-effective data transmission. At the end, these kind of setup will also save money. So I'm at the end of this presentation. As a summary, I want to say IPP capable data loggers are an investment in today's and tomorrow demands. The IP technology offers new possibilities for data transmission regarding availability of data, redundancy mechanisms, and last but not least, cost-effective data transmission. Odd netDL data loggers, together with the well-established high-quality odd sensors, are utilizing the IP technology to build up high available, reliable, and scalable measurement networks and secure therefore the investment for the future. Thank you very much for your attention.